Right now, hundreds of millions of miles from Earth, a spacecraft is coasting through the deep freeze of the main asteroid belt. It is moving at tens of thousands of miles per hour, carrying a suite of instruments designed to look back in time. Its mission was carefully mapped out long before launch. It was supposed to ignore the main asteroid belt entirely and head straight for the dark, unseen swarms of rocks orbiting near Jupiter. But in November 2023, trajectory analysts realized the flight path would bring the spacecraft relatively close to a rock no one cared about, a half-mile-wide piece of debris drifting silently between Mars and Jupiter. The science team decided to wake up the cameras. It was just a test run, just to make sure the tracking systems worked before reaching the real targets years later. What they got back was not a routine confirmation image. It was something that had never been seen before in the entire history of space exploration. A tiny moon made of two separate moons, orbiting an asteroid that had literally shaken itself apart. Why was it there? How did sunlight alone create an entire miniature planetary system out of a single rock? And if a target this small and supposedly boring is this complex, what happens when this spacecraft finally reaches the primordial targets it was actually built to find? You're watching Beyond the Signal, where we follow the evidence to the edge of what science knows. To understand what NASA is looking for in the dark, you have to go back to November 1974, the Afar Triangle in Ethiopia. A paleoanthropologist named Donaldjohanson was walking through a dry, dusty ravine when he spotted a piece of bone protruding from the earth. Then another. When the excavation was finished, his team had uncovered 40% of a skeleton belonging to an ancient human ancestor, roughly 3.2 million years old. He named her Lucy. That single discovery fundamentally shifted our understanding of human evolution. It proved that our ancestors walked upright long before they developed larger brains. It was a physical record, a fossil that held the memory of our biological origins. Fast forward to the 16th of October 2021. Cape Canaveral, Florida. An Atlas V rocket violently pushes a new spacecraft off the launch pad, sending it on a 12-year, 4 billion-mile journey into deep space. NASA named the spacecraft Lucy. The connection is not just symbolic. It is literal. Just as the fossilized bones in Ethiopia gave us a window into the origins of humanity, this machine was built to find the fossilized remains of the solar system itself. To see why this mission is so necessary, you have to look at the ground beneath your feet. Earth is a terrible place to study history. Our planet is geologically alive. It has plate tectonics, erupting volcanoes, deep oceans, and a corrosive atmosphere that constantly recycles and destroys the past. If you want to know what the solar system looked like 4.6 billion years ago, you cannot look at a planet. The evidence has been paved over, melted down, and buried. Instead, you have to look for the leftovers, the debris, the rocks that never grew large enough to become planets, rocks that have been sitting in the cosmic deep freeze since the very beginning. Early in our solar system's history, there were no planets. There was only the sun, surrounded by a swirling, chaotic disk of gas and dust. Close to the sun, it was blistering hot. Any water, any volatile chemicals, were vaporized. Only heavy materials like iron, nickel, and silicates could remain solid. That is why the inner planets, Mercury, Venus, Earth, and Mars, are made of dense rock and metal. But further out, past the orbit of Mars, the temperature plummeted. This boundary is called the frost line. Beyond this point, water could freeze into ice. The objects that formed here were different. They were mixtures of rock, water ice, and organic molecules. These were the building blocks of the giant planets. But not all of those building blocks were consumed by Jupiter and Saturn. Millions of them were left behind. These leftover planetesimals are the asteroids. Most of that debris is locked in the main asteroid belt between Mars and Jupiter. But Lucy is not heading there. It is heading somewhere much further and much stranger. It is going to the Jupiter Trojans. Think of Jupiter not just as a planet, but as a gravitational anchor. As it orbits the Sun, its immense mass creates dead zones, pockets of stability where the gravitational pull of Jupiter exactly balances the gravitational pull of the Sunday. These are called Lagrange points. There is one pocket flying 60 degrees ahead of Jupiter and one pocket trailing 60 degrees behind it. Over billions of years, these gravitational dead zones have trapped tens of thousands of asteroids. Two massive, dark swarms of rocks locked in a perpetual escort of the giant planet. No spacecraft has ever visited them, not once. And here is the part most headlines miss. The Trojans likely did not form near Jupiter. According to the leading models of orbital dynamics, specifically the Nice model, the solar system experienced a period of extreme violence early in its life. The giant planets Jupiter, Saturn, Uranus, and Neptune migrated. They shifted their orbits. When this happened, their immense gravitational fields swept through the solar system like a snowplow. Trillions of icy bodies from the outer edges were violently scattered. It was an era of cosmic chaos. Many of these objects were hurled into the inner solar system, but some of those scattered objects were caught. They were swept up by the gravity of Jupiter and funneled into the Lagrange points. If that model is correct, the Trojans are refugees from the outer dark. They are pristine samples of the original material that built the planets, preserved in a gravitational vault for 4 billion years. To understand them is to understand how the Earth was built. But getting there requires an engineering miracle. To reach the Trojans, Lucy cannot just fly in a straight line. It has to borrow momentum. Over its 12-year mission, it swings past Earth for gravity assists, slingshotting itself deeper into space. The spacecraft is roughly the size of a small building when fully deployed. Because it is flying so far from the sun, it cannot rely on small solar panels or nuclear batteries. It requires 2 massive circular solar arrays, each nearly 24 feet across, unfurling like enormous fans to catch whatever faint sunlight exists out by Jupiter. And shortly after launch in 2021, that intricate system almost failed. One of the massive arrays deployed, but it did not lock into place. It was soft, unlatched, held open only by tension. Put that scenario in perspective. You are sending a spacecraft into the coldest, darkest regions of the planetary system. Power is everything. If the solar array collapses under the stress of an engine burn or a gravity assist, the spacecraft loses power. The heaters fail. The delicate instruments freeze. The mission dies. For months, engineers at NASA and Lockheed Martin analyzed the data. They realized a lanyard used to pull the array open had snarled. They designed a high-risk fix, firing the primary and backup deployment motors simultaneously to forcefully snap the array into a stiffer position. It was a tense maneuver. But it worked. The array stiffened enough to handle the long journey. Lucy was safe. With the power crisis resolved, the spacecraft settled into its long coast. To reach the first Trojan swarm, Lucy had to fly through the main asteroid belt. In early 2023, trajectory analysts noticed that Lucy would pass within a few million miles of a tiny, unnamed rock. They fired the thrusters, adjusting the course just slightly. They named the rock Dinkinesh, the Amharic name for the Lucy fossil, meaning, "You are marvelous." It was chosen purely as a target for practice. When you fly past an asteroid at 10,000 miles per hour, human controllers on Earth cannot steer the cameras. The delay in radio communication takes too long. The spacecraft has to spot the target, lock on, and pivot its instruments entirely on its own. Dinkinesh was tiny, only 790 meters across, or roughly half a mile. It was considered a generic, boring rock, the kind of thing you use to calibrate your lenses before the real show begins. On the 1st of November, 2023, Lucy flew past it at a distance of just 270 miles. The encounter lasted only minutes. When the data trickled back to the Deep Space Network antennas on Earth, the science team expected to see a small, heavily cratered potato. Instead, they saw 2 objects. Dinkinesh was not alone. It had a moon. That alone was surprising. Binary asteroids do exist, but finding one by accident during a test run on a half-mile rock is statistically incredibly lucky. But then the high-resolution images arrived. And the story changed. The moon, which scientists named Selim, was not a sphere. It was a contact binary. 2 distinct rocky lobes gently pressed together, fused at a narrow neck, orbiting the main asteroid as a single unit. Think about what that means. We have sent spacecraft past dozens of asteroids and comets. We have seen contact binaries before, most famously the object Arrokoth far out in the Kuiper Belt. But we had never seen a contact binary acting as a moon orbiting another asteroid. What was supposed to be a boring calibration target had instantly become a completely new class of celestial object. The data raised an immediate question: how do you build a double moon around a tiny rock? The answer, published in the journal Nature in May 2024, revealed an asteroid environment far more dynamic than anyone expected. When scientists looked closely at the main body of Dinkinesh, they noticed 2 distinct geological scars. One was a deep trough running along its side, the other was a prominent ridge wrapping around its equator like a belt of rubble. These were not impact craters. These were structural failures. That sounds technical, but the idea is simple. In the vacuum of space, asteroids are subjected to something called the Yorp effect. As the sun heats the uneven surface of an asteroid, the rock eventually radiates that heat back into the cold vacuum. Because the shape of the rock is irregular, the thermal radiation pushes unequally. It acts like an incredibly weak thruster. Over millions of years, without any friction or air resistance to slow it down, this microscopic push causes the asteroid to spin faster and faster. For Dinkinesh, the Yorp effect became a destabilizing force. The asteroid is small, and its gravitational hold on its own surface material is incredibly weak. If you stood on the equator of Dinkinesh, you could easily jump off into deep space. As the sunlight spun the rock up, the centrifugal force at its equator began to rival the force of gravity. The asteroid literally began to shake itself apart. A large chunk of rock fractured and slid outward, leaving behind the deep trough. Some of that debris fell back down, piling up to create the equatorial ridge, but some of the material was thrown into orbit. Over time, that ring of loose debris coalesced. It clumped into one moon. Then, perhaps thousands of years later, the asteroid spun up again, shedding more material, forming a second moon. Eventually, those two moons drifted closer together in their gentle orbits until they touched. They did not shatter. They stuck together, forming Salem. The entire system was sculpted by nothing but sunlight and gravity, turning a solid rock into a miniature, evolving planetary system. If that is what Lucy found on a practice run, what will it find next? The mission is currently racing toward its second target in the main belt, scheduled for the 20th of April 2025. This asteroid is larger, about 4 kilometers wide. It is named Donaldjohanson, honoring the paleoanthropologist who found the original fossil. We know it is rotating roughly every 10.5 days, but more importantly, we know where it came from. Donaldjohanson belongs to the Aragon family. About 130 million years ago, during the time dinosaurs walked the Earth, a massive asteroid, perhaps 100 miles wide, was struck by another object. The collision shattered the parent body, sending fragments drifting through the main belt. Donaldjohanson is one of those fragments. Lucy will fly past it at a staggering 30,000 miles per hour, closing to within 600 miles of its surface. The science team will be looking for clues about the interior of that ancient destroyed parent body. By looking at Donaldjohanson, they are essentially looking at the exposed core of a much larger world. Could it have water-bearing minerals? On previous missions, like NASA's OSIRIS-REx at the asteroid Bennu, scientists found clays rich in water chemistry. If Donaldjohanson shows similar signatures, it adds another piece of evidence to one of the biggest open loops in planetary science, the origin of Earth's oceans. Earth formed too close to the sun to hold on to liquid water. It was baked dry. Our oceans had to be delivered later, likely by ancient asteroid and comet impacts. Every time we find water chemistry in the asteroid belt, we are tracing the supply chain of life. But based on Dinkinesh, scientists are preparing for the unexpected. Donaldjohanson might not be a simple fragment. It might be tumbling on multiple axes. It might have hidden moons of its own. The only certainty in deep space exploration is that reality rarely matches the model. All of this, the solar array crisis, the double moon of Dinkinesh, the upcoming high-speed pass of Donaldjohanson, is just the prologue. In August 2027, Lucy will finally cross the threshold into the L4 Trojan swarm ahead of Jupiter. Its first primary target is Eurybots. It is a massive object, roughly 40 miles across. And just like Dinkinesh, it holds a secret. Shortly before Lucy launched, the Hubble Space Telescope spotted a tiny speck orbiting Eurybates. It has a moon, now named Queta. After that, Lucy will target Polymele, which also possesses a recently discovered moon. Then it flies past Lucas, an asteroid that takes a bizarrely long 446 hours to complete a single rotation. Then Orus, a dark, reddish rock that might be rich in organic compounds. And the mission does not end there. In a display of orbital mastery, Lucy will fall back toward the inner solar system, fly past Earth again in 2030 to steal more momentum, and hurl itself all the way across the solar system to the L5 swarm trailing behind Jupiter. In 2033, it will reach Patroclus and Menoetius. This is not a rock with a tiny moon. This is a massive binary system. Two objects, each about 70 miles across, orbiting a shared center of gravity. Scientists believe these two massive bodies have been locked together since the very dawn of the solar system, entirely undisturbed by the planetary migrations that shaped everything else. They are the ultimate time capsules. There is a profound symmetry in this mission. When Donaldjohanson brushed the dust away from those fossilized bones in 1974, he was looking for the physical evidence of how human beings adapted, stood up, and began walking across the Earth. He was searching for the mechanism of our biological survival. Right now, a machine bearing the same name is coasting through the dark, hundreds of millions of miles away, looking for the physical evidence of how our planet itself was built. It is searching for the raw materials, the carbon, the silicates, the frozen water, that eventually coalesced into a habitable world. Both endeavors are driven by the exact same instinct: the refusal to simply accept our existence without understanding how it happened. Every time humanity has pointed an instrument at something new, the universe has proven to be stranger and more complex than our best theories. A half-mile rock shaking itself apart to build a double moon was never in the textbooks, but it is in the sky. What Lucy finds out in the deep freeze of the Trojan swarms may finally explain how the chaos of the early solar system settled into the calm, predictable orbits we see today. Or it may dismantle those theories completely. Either way, the evidence is out there, waiting in the dark. Tell me which part of this journey changed how you think about the objects floating in our solar system. This is Beyond the Signal. Keep looking past the obvious.